Beaming around the world with the latest science and space news on Facebook Watch, YouTube, and wherever you get your podcasts. This is Talkin' Science with Dr. Brad Tucker and Matt Miller.
And the man of many science is with me once again, as he is every Tuesday, Dr. Brad Tucker. Happy Tuesday for Talkin' Science.
Yeah, how's it going?
Really good. October has finished. This is crazy.
Yeah, rolling over, ticking over, moving on. It's a busy year.
It absolutely is. Halloween is coming up this weekend. The 20th anniversary of the space station. We'll be talking about those things in the headlines today. Very exciting. And of course, to find all the information, we're going to find you on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook. I'm on Twitter at Miramat86. And of course, Trekzone all over social media. Plenty of great stuff coming as we head towards the end of 2020. Be sure to like, follow, and subscribe to Trekzone all over social media. Ring the bell to never miss a moment. Brad, it is time to talk science.
Talking Science headlines.
And first up in our headlines this week, Brad, this Saturday, it's Halloween, but more importantly, from a space perspective, we're getting a very special blue moon.
Yeah, so not only will it be a full moon on Saturday and Halloween, which is always fun, it's a blue moon. So no, the moon won't look blue, but it's what we call, once in a blue moon. So it takes 29 and a half days to get between each lunar cycle. So, 29 and a half days roughly between full moon to full moon. So you don't often get two full moons in the same month because it's about 30 days and there's 30 days usually to 31 days in the months. However, if you get a full moon at the beginning of a calendar month, you may slide one in at the end. And this is what's happening on Halloween. We'll have our second full moon of October, which we call a blue moon.
That is very cool. And another cool thing happening in space, marking the milestone of 20 years of continuous human habitation of low Earth orbit, the International Space Station celebrating a milestone.
That's right. It's reached its 20th birthday, and it's been a remarkable, obviously, machine, experiment lab in space. That's been doing some amazing things. This dream that was, built 20 years ago or finished and started to be inhabited 20 years ago, which took many more years to build, was a very ambitious project to get the US and Russia and other countries to work together on an international space station. And what seemed quite distant at the time has now turned into a very successful, I think, scientific lab that we use for lots of different things.
It really has broadened our understanding of space habitation, space missions, given us the opportunity to research quite a lot of things that we didn't quite understand before, starting off in low Earth orbit in the 60s and 70s with very simple missions, simple in inverted commas, but only lasting a few days, to year-long experiments, and now very regular missions lasting up to quite a few months. So really pioneering the way forward and really giving us that opportunity to make Artemis happen. Artemis missions to the moon and to Mars, of course, happen a bit more easily, if you will, with the understanding of what's going to happen to the astronauts already in the bank.
Yeah, it allowed just a wider variety of science to happen, and as projects and stuff came up, you knew there was a platform or a place you can do it. And over time, access and evolution has evolved in the sense that other countries have come on board to participate, but now different private companies have their own ports or access that allow experiments and researchers to do. And it ultimately is cheap. Instead of everyone building a space station or building a satellite to do their individual experiment, you have a place where they all can be done relatively cost effectively compared to other things in space. So it's definitely been, I think, over the long run, a huge savings of what could have been.
Well, let's reverse the viewpoint for our next headline because we talk about exoplanets every now and then here on the show using the Transiting Exoplanet Survey Satellite, or TESS, and a team of US astronomers have used that satellite and a European satellite as well to identify 1,004 main sequence stars that potentially have habitable worlds that could look back on our planet as an exoplanet.
Yeah, it's kind of an interesting idea that we look from our view, a planet to pass in front of that star, look for that dip, determine there's a planet. So this paper said, all right, let's flip that. What if those planets are looking at our sun? Will they see Earth going in front of our star, the sun, as viewed from their planet, seeing a dip and therefore be able to detect Earth? Earth is a relatively small planet, fairly far out compared to the planets we find. So our blip or our transit is actually relatively small. And so it's a big question of if these planets had life and they had telescopes, could they, detect Earth? It's an interesting thought experiment. The fact that they think, just over 1,000 planets could build facilities to detect our life, so to speak, our planet, is quite cool.
Kind of opens the possibility a little bit. When you say 1,000, it's a little bit better than saying just a handful. So there is a strong possibility if there is complex life out there and they have telescopes that they could be watching us transit past the sun.
And then you also say that, the flip of it is, well, it actually then starts to think that, well, even though there may be, billions or even trillions of planets in our galaxy, heaps of planets, a lot of those won't be able to necessarily detect, at least at the technology we think of today, our planet, or in the past or the future, just know our planet exists. So it just shows how big kind of space is and how limited to some degree we may always be in that quest for understanding of other life in our galaxy.
Now, all these stars are within 100 parsecs, or about 326 light years of Earth, so not far out, not too close, but not too far out.
Yeah, it's finding that sweet spot for detecting it and be the habitable planets that we think about and care about. And again, we're not talking about even just now, that in the history of that planet, in the history of our planet, could a life form, if it evolved and developed and could they detect Earth? So it's at least an interesting discussion of, are we ever going to be seen? Not us to see something, but us to be seen. And there's a chance.
And if we have been seen, they could be on their way for all we know.
That's right. They could be here or they could see us tomorrow and then arrive in 1,000 years.
Talking Science, Stories of the Week.
Alrighty, Brad, stories of the week time, and Osiris-REx. We teased this one last week, waiting with bated breath to see what would happen. It did kiss the surface, as you will. It did the touch and go maneuver, the tag sample collection event. Unfortunately, it was a little bit too exuberant.
Yeah, look, one of the big worries was obviously, would it get to the surface? Would it actually touch down? Would it grab stuff? All that sort of thing. Which was a big ask, so to speak, and a big risk. However, it did it quite well. It reached, they estimated anywhere between about 30 to just shy of 50 centimeters, so actually relatively deep. The problem is they did that too well. Not a problem they were necessarily expecting to get down and actually end up grabbing too much stuff. And this is the issue where they lie now, is that there is too much stuff in Osiris-REx. The lid is stuck open, and they're actually now losing material out into the vacuum of space.
And there's no quick fix for this, is there? The engineers have to come up with a way to send commands to the spacecraft to try and get that lid closed. It's not like there's a shuttle nearby that can just pop over and make a repair.
Yeah, exactly. These are one of these things where, like rovers on Mars, you have to do a lot of work to try and reboot, remote fix, all those sorts of things. And it is an issue. If they don't get it fixed, they could and run the risk of losing all of their sample, which would just be heartbreaking. So something they obviously want to get a hold of so they get as much stuff as they possibly can back to Earth. This was the worry we talked about, was they end up with nothing or just tiny amounts getting back to Earth. And so that's exactly desperately what they're trying to avoid.
I can only imagine the feeling in the control room as this telemetry came in, the successful touching of the surface, then to only learn that it was, and that's an accomplishment in and of itself, and then to learn that unfortunately it may not have, or it may have been too good, and there are problems. Such a mixed emotion sort of day for the team working on Osiris-REx.
Yeah, exactly. Yeah, I think mixed emotion is right. They had to desperately wait that the touchdown happened. They did, which they waited with bated breath, then realized, hey, we got it. We got lots of stuff. Great. Oh, wait, we got too much? Yeah, definitely a bit of a roller coaster for the team there.
Absolutely. And to think that, we can land on asteroids now, send a spacecraft out and compute all of that telemetry ahead of time and work it all out and land on or touch and go on an asteroid in Osiris-REx's case is, it's an incredible feat.
It really is. And I think, as we talked about with Hayabusa, for instance, very impressive missions that are going to tell us a lot. So glad to see these things are successful and working and achieving the targets they want. You obviously don't want them to fail. You don't want them to have these issues going forward, because it is quite a disappointment for everyone involved. So hopefully they can get a handle on it at some point and gets it fixed, because that's the last thing you want to happen, both for the team and scientifically.
Yeah, absolutely. Well, just reading what actually went into this tag maneuver, or the touch and go sample acquisition mechanism, its operation, all occurred within about 6 seconds. It touched down. A second later, it fires a nitrogen gas bottle, and within 3 seconds, it's got its sample and it's pushing away from the asteroid again. Just incredible. I'm just in awe of this engineering. Is I think where I'm heading with this.
Yeah, it's a really quick process to reach down, as you said, do the pushing of the air maneuver, and then have that kind of suction cup vacuum magnetic thing scoop up as much as you can. Again, really a really impressive feat all around. So it's not. So being stuck open is not how you want it to end, given how complicated it was with something that's kind of relatively simple, and stuck open because it got jammed open of all things.
Yeah, absolutely. Well, if they can get this right, it will be returning to Earth, and I believe it's going to be touching down in Utah.
That's right. It will return in Utah in 2023. So it has a long trip ahead to get back to Earth and get the samples and all those sorts of things, which is again why they can't just leave it open for the next 3 or 2.5, 3 years. It's not like it'll be popping down tomorrow, so they can just kind of quickly run it home. A long journey ahead back, which is just complicated enough, to be honest, to return back. And then when they get back to Earth, to actually deposit or drop the samples on Earth, all of that is another big, hard feat that they'll have to solve. So, trying to eliminate as many problems for them as they can.
Well, Brad, next up in our stories of the week, and this one is pretty crucial. I was debating whether to put this one in the headlines and bring up the 20th anniversary of the space station, but I think putting it in the stories of the week really shows just how important it is for our American friends to be voting, and those that don't vote. It's such a radical concept for me as an Australian to know that the voting isn't compulsory in the US. But some NASA astronauts, or NASA astronaut Kate Rubins, has taken it to the next level. She's voted from the space station.
That's right. And it's when you look at the US law, secret ballot, all that sort of stuff, they don't really do electronic voting in the way other countries and places Australia really does. And so in this case, obviously her ballot can't be mailed to her or anything like that. It has to be sent via electronic transmission via NASA. And so Texas law has a provision that allows remote voting from a very special place called low Earth orbit, which allows a special set of procedures to be done to allow astronauts who are in space to vote.
It is very cool reading up on this one. They've had this law in place since about 1997. It's a concession to the fact that most astronauts live near the Johnson Space Center in Houston. And it's a pretty extreme absentee procedure where they get to write their address as low Earth orbit. I couldn't think of anything cooler.
Yeah, that really is, right? What is your reason for needing to do absentee balloting? I'm in low Earth orbit. and you're right. It's only Texas that does this because the vast majority of especially active NASA astronauts live in Texas and specifically Houston, which means that, it just clearly they needed a way to do this. It was not something they could just completely ignore. It's something they had to address. So they found a sensible way to take the ballot from the Texas Board of Elections, submit it to NASA on behalf of that person. NASA electronically sends it to astronaut or astronauts in space. They vote, send it back to NASA, and NASA submits it on their behalf.
It's something that you don't think about until it actually comes up, really, because it's an option that should be provided to the astronauts, and it has to be done in such a way as not to expose the data while being transmitted, because that's the whole point of voting, that you vote in secret.
Exactly, that's right. It's one of those things where, all right, well, is that simple? Well, kind of yes, but kind of no. You have to suit the integrity of secret ballot and what the voting means, but also be able to allow people to have the option. You just can't say, oh, too bad, so sad, you're in low Earth orbit. Lots of provisions are made for people to do their voting. So it'd be disappointing if a certain set of people who were in service ultimately to the U.S. lost that opportunity. So it's one of those things where it is an important thing, and it's glad that NASA's been NASA and thought of all these little details to happen. It's and thinking about the next presidential election, or at least the one after 2028, and other elections in between. You may need to have your location as on the moon instead of low Earth orbit.
Yeah. It also makes me wonder about the Defence Force. Surely they have procedures in place very similar to this as well. I guess a little bit more mundane. I'm just in a US base in Germany or in somewhere else. But low Earth orbit still takes the cake.
Yeah, look, I mean, so Defence Force overseas voters. There's lots of easy ways of doing it at an embassy, your base, mail. You can fax votes in. You can personally fax if people remember that old technology. And I have faxed my vote into California, where I'm a registered voter. So you could do all that. Just none of those options exist in the space station. And more importantly, if they physically mail you a ballot, it's usually anywhere between 6 weeks to about 3 months, roughly, pre the election. And if you're in space for 6 months, you can't even mail it in. And your time in space is a lot longer than that window. So none of those options that are quite easy to be solved relatively for various groups on Earth is not an option for those in space.
Well, Kate Rubins arrived in orbit for her second space flight on October 14. She's going to be the only American astronaut on Election Day habiting the space station. That's, of course, November 3. And she's going to be staying up there for about 6.5 months. In addition to Kate, they had also planned for the Crew 1 mission, the astronauts of the Crew 1 mission, to also vote from space, but their launch has been delayed until mid-November. So Kate's got the honour this time around, and it only comes up once every 4 years.
Yeah, that's exactly right. They were looking at multiple people needing to vote, but only one this time. But as you said, it's a law that's been around for a number of years, quite a while, and it's been utilized quite a bit, and it will continue to be utilized in the future.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
Alrighty, Brad, last up this week, we're off to the moon, and some new details that have been revealed overnight indicate that it may be wetter than anyone thought.
Yeah, water, or at least ice, has been a big deal since it was really hinted at, 11 years ago or so. and studied in detail in the past number of years. And the question has always been, what is exactly the compound? How much of it? Where is it? All those sorts of things, because water is the key ingredient for supporting human exploration to the moon. And it's not just because we can drink it, but because it is the ingredients for rocket fuel, and a relatively easy one to refine and turn into rocket fuel, so to speak. It is H2O. And so there's been a lot of work into trying to understand this. And a new study from SOFIA, which is a telescope mounted in a 747, actually, has detected signatures of lots of H2O.
I just want to touch on the Stratospheric Observatory for Infrared Astronomy, or SOFIA. As you say, it's on board a Boeing 747. It's a 2.7 meter telescope that flies above 99.9% of the water molecules on Earth. So that's pretty high. It's just flying around and just has a giant hole in its belly. Or I would assume it's not a hole, but it's got a window out to the universe from all the way up there. That is very cool.
When we look in the near infrared wavelength, so we're talking about colors that are redder than red. In this case, it's looking at anywhere between 3 to 4 microns, as we call it, micrometers, all the way up to, I think 10 to 15. Those areas are affected by other parts of the Earth's atmosphere, in particular water vapor and water absorption. And when we look at this, the issue is you can get high enough in the atmosphere to get rid of most of it. It's not something where it's ozone, where you have to be at 20 kilometers or other parts of the atmosphere that block different wavelengths. There's just not obviously many mountains that are super tall that could reduce much of that. And obviously you want the ability to look at different hemispheres so you can see different targets and sorts of things. And so this project was envisioned, and it's not the first. There's been previous, the Kuiper Airborne Observatory that did this to say, hey, if we get high enough, we can look in these wavelengths and do really cool astronomy all the time. And so a retrofitted 747 was built that has a port out the port side, back port side, that where the telescope is mounted, and it does their astronomy. And so they do these flight plans every night to, depending on where the target is, they fly around it. And so they do seasons where they're flying out of California and seasons where they're flying out of New Zealand to pull this off.
And it's found these water molecules in Clavius crater. It's one of the largest lunar craters visible from Earth. It's found about 100 to 412 parts per million, which is roughly equivalent to a 12-ounce bottle of water. And you can tell that I'm reading an American article on that because I don't have my instant conversion available. But that's a 12-ounce bottle trapped in 1 cubic meter of soil. So it's not a lot, but it's more than what we thought was there.
More than what we thought was there. And there's two keys here. One, where the exact location was, as you said, that it's not just one particular spot. There are other spots that appear to have this, but also that the signature they have is clearly just from H2O. So why is this an issue? So there's what's called the hydroxyl molecule family. So hydroxyl just means involving hydrogen and oxygen. So for instance, peroxide, OH, that is a hydroxyl compound. Water also is as well. So it could be other combinations that are not just water. When they saw this signature, which occurred around 6 micrometers, 6 microns, this line can only be from H2O in essentially a liquid state, what we're talking about, not ice or anything like that. That the reflection here that they detected of light was from indeed just purely water. So it's kind of, it's that continued discovery that we're refining exactly what is on the surface, where it's on the surface, and how much volume is on the surface, as you said, which is another key factor here.
Now, the Sahara Desert has about 100 times the amount of water than what SOFIA has detected. It doesn't diminish the fact that there's water there, because without a dense atmosphere, this water should be lost to space. So how is it hanging around? It's one of the biggest questions.
That's right. It is. It's obviously trapped there. It's stuck there. So it's a really big thing. That they're finding that this water is really stuck or trapped around the surface and still bound to the surface. This is going to be key for NASA and everyone's goals to the moon. So understanding more how it's created, how it is created, how it's maintained, how it's kept, and in what quantities is a big question going forward for our future plans for the Artemis mission.
Yeah, well, one of those future plans is the Lunar Compact Infrared Imaging System. It's basically a preemptive robotic lander to the moon in a couple of years, I guess, to really work out what's going on up there before we send some humans and really create a task list for those humans that make it to the moon.
Yeah, really kind of scouting future options, future sources, all that sort of stuff before humans arrive. Really scouting, the best locations and the best volume. And this goes back to an issue we talked about a couple of weeks ago with things like the Artemis Accords and some of the legal issues. One of the big issues has always been, if there's only a few pockets of this stuff, will there be competition and land grab and issues of future people and countries and companies going to the moon? And that's not what people want. So the question is, and obviously an easy way to solve it, is finding how much or where all this stuff is, and then getting it pinpointed so that lots of countries can map where they're going to land, map where they're going to operate, and avoid those potential future political tensions and issues.
Fantastic, Brad. Well, it is fun to pick apart the stories of the week with you, and we're going to do it again next Tuesday. Some cool things still to come for the rest of the year, and we're not going to stop until Christmas as we fast approach 100 episodes too. This is episode 98 of Talkin' Science, so we should get the party poppers and the balloons ready.
Exactly, that's right.
Thank you very much, sir. We'll catch you again next week.
Great.